It's time to form our first failover cluster. In this nugget, we're going to jump right into the virtual lab and do just that. We'll start with our shared storage layer. We need to configure an iSCSI target over on our file server, and then we'll look at the many ways that we can create a cluster and get familiar with the tools that we'll be using to manage it. Let's jump in. I've already logged into our remote administration machine, adminnug. Let's start here by getting right in to Server Manager. So we'll launch that using the icon down there in the taskbar. Once it fires up, hit all servers over there in the left-hand nav, and we should get a good look here at all 4 of our machines. So the first thing we're going to do here is configure shared storage on fsnug. So we're going to use iSCSI, configure a target, and then we'll set up some initiators in both cluster 1 nug and cluster 2 nug so they can utilize and see the LUNs over there on that iSCSI target. Once we have our shared storage layer set up, then we will form a cluster out of CL1 and CL2 nug. These will both be nodes inside of the cluster. We'll then configure networking. We'll also need to configure a witness because we have an even number of nodes in the cluster, and I'll also show you how we can manage and configure quorum. So let's begin by getting that shared storage layer over on fsnug configured, and we're going to use PowerShell for a lot of this. So let's go ahead and launch File Explorer, and we'll go right into the C drive here, into the Nugget Lab directory, and we will right-click on PS Commands and launch it into the ISE. Now, before we get over to fsnug to create the iSCSI target, we're going to do a little pre-configuration that'll make it a lot easier when going through the GUI and hooking up our initiators to the target. But the first step you will always want to do is start the iSCSI service on both of your cluster nodes because it is turned off by default. So we're going to get the service, we're going to pipe that over to set service to make it startup type automatic, and this would end the PowerShell pipeline right here, which is why we need the pass-through parameter, which will continue on the pipeline because we also need to start the service. So get the service, set its startup type to automatic, and fire it up. And we're going to do an invoke command here to send this over to both machines in one shot. Let's do it. Now, with the service running, we should be able to run a get initiator port against both of what will be our iSCSI initiators here, CL1 and CL2 nug. I'm going to go ahead and run this command, and this is going to return 2 result sets here. And the important bit to know is right here, this IQN. This is the node address in the form of its IQN, fully qualified domain name. This is what you will need when we configure our iSCSI target. We can put in an IP address, DNS name, or the IQN, which is the node address here for this initiator. So we could pop this in manually, cut and paste and all that, but this pre-configuration step, in fact, the next PowerShell command here will cache that address at our target over in fsnug, which will make configuration a lot easier. You'll see what I mean in the wizard here shortly. But what this command will do then is essentially allow our targets to discover the initiators, which is why we're specifying the target portal address here as .3.105. This is the 3 network, our storage network, that we configured on a network card over on our file server, fsnug. So by running this on both CL1 nug and CL2 nug, it's going to cache their IQNs over there on fsnug for the target when we configure it. So I'm going to go ahead and run this, and then I'll just take a second, and we're good. Now, if this was not available or not online or couldn't see our file server for whatever reason, then this would have came back with an error for both of these. But this tells us that we're good, and our initiators can communicate over there on our storage network with fsnug. All right, so we're all done with our initiators for now. We'll be back to them when we want to connect up to our target. But our next step is to create that iSCSI target over on our file server. And we're going to do this using the wizard in the GUI. But I just want to point out this is the PowerShell way of doing it. And this is exactly what we're going to accomplish in the wizard. So let's head back here to Server Manager. And let's choose File and Storage Services. And let's start here. Here is our file server. I want to do one thing here. Let's go and right-click on that and choose the iSCSI target settings. What we want to do is lock down communication here to our 3 network. That is the node address that we chose when we set up that portal. And this is for the cluster. We only want communication to our storage, to our iSCSI shared storage here on that 3 network. So we're going to uncheck the 1 network. And there we go. All storage through iSCSI, all communication, I should say, through iSCSI storage will go through the 3 network. And we'll go ahead and hit OK. Now we can hit the iSCSI node over in the left-hand nav. Notice that we do not have any virtual disks. We do not have any targets created yet. So let's drop down the task button. You can also hit this link right here and choose New iSCSI Virtual Disk. This will launch us into the wizard. So in the wizard here, we're going to select a volume. I've got a D drive attached over there to fsnug. It's 50 gigs in size. So we can choose the volume here and hit Next. Now we can give it a name. Let's call this one, how about CL Disk? This will be our main storage for our cluster, and we'll go ahead and hit Next. Here, let's give it a size. We'll call this one, how about 100 gigs in size? It'll be dynamically expanding, and hit next. We don't have any targets out there yet, so we're going to create a brand new iSCSI target. We'll hit next, and we'll give this one the name, how about CL target, and hit next. Here's where we're going to choose our access servers, and this is why we did that pre-configuration step, to make this much easier. Because if we hit the add button here, we should see both of those initiators, IQNs, cached. So if we didn't do this here, again, we could enter a value. We could just paste the IQN in, or we could enter in for any of these other properties here. But let's go ahead and just choose the first one and hit OK. Then we can hit add again, choose our second one, and also hit OK. And there we go. We've now, both of these initiators will be able to see and utilize this target. So we're good here. Let's go ahead and hit next. Optionally, you can enable chat authentication here if you want some authentication between your initiators and your targets. We're good, so we'll go ahead and hit next, and we're done. We can hit create. And that's that. We'll hit close here, and we're going to create one more here that we can utilize as a witness. So let's drop down tasks and choose new iSCSI virtual disk. Make sure you choose the D volume there, hit next. We'll give this one the name, how about CL Quorum, just like so, and hit next. This one, we only need a gig. Actually, it can even be less than that, but we'll just choose a gig here and hit next. We're going to choose the same target. That way we'll only need to initiate once. So this target will get access to both of the virtual disks within here that we can, again, slice LUNs off of. So we'll hit next here, and we're done. Create and close. So we've got two iSCSI virtual disks ready to go. One for storage in our cluster and one for Quorum. Notice that nothing is connected right now, but we did specify our initiator IDs. So the next step then is to create that connection on our initiators so they can utilize the shared storage. Also, if you scroll down here, you will see our target. So let's head back to PowerShell. We're going to need PowerShell for this, and let's scroll down a little bit here until we see our post target iSCSI initiator. The first thing we're going to need to do here is update that portal so it can get all the metadata around the target that we just created. And that way, it can discover the targets here from the initiator. Because if we ran this right now, it's not going to return anything. See that? Nothing. But if we update the information here inside of our portal for, again, discovery, then we can run that again and it'll work. So we can just run a get iSCSI target portal, pipe that over to update, and that'll pull down all the latest information about that target since we created it over there on FSNUG. Now if we run this, get iSCSI target, we should see for both of those that it has a target available. So our final step is to run a get iSCSI target like we just did and pipe that over to connect iSCSI target. This will give both of our nodes here access to that shared storage. So that'll create a connection right to the target from these initiators. And what this will return here is all the properties around the connection itself, the session. And notice here one of them is persistent, is false, which is the default, which means if our nodes were to ever reboot, then they wouldn't automatically connect up to that target, and we would need to manually connect up. So that's what our final step here is all about, where we can take that existing session, pipe that over to register, which will flip the is persistent flag here to true, meaning that connection will persist across reboots. So I'm going to go ahead and run this one more time, and now we're good. Now we can head back into Server Manager, and let's head up here to disks, and we should see those disks available here on both of our cluster nodes. We may need to refresh Server Manager here to pick that up, but what we should see is both of those disks available on both Cluster 1 NUG and Cluster 2 NUG. Check it out. So now what we need to do is bring them online and initialize them, and we'll only need to do this once because these are both pointing to the same disk over there on FSNUG. So we'll right click, let's do our 100 gigabyte disk first here, we'll bring that online. Go ahead and choose yes at the message, and it's on. Now we can right click again, we can initialize it, hit yes here, that'll turn it into a GPT disk, perfect. And finally here, we can create a new volume on it. Walk through a very familiar wizard here to create this volume, perfect, everything looks good there. Looks good here, we can accept the default of 100 gigabyte volume size. We'll keep the drive letter here of D on both of our cluster nodes for data. We'll hit next. And let's just go ahead and change the volume label here as well to data. We'll hit next and create. All right, and that one is done. And we'll see that actually reflected down here on our second node as well. See that? Totally ready to go. Let's do the same thing here for our quorum or our witness. So we'll bring this one online. Choose yes at the message. We'll right click again. We'll initialize it as a GPT disk here. So hit yes. And then finally, we will create a new volume on it. We'll go ahead and just fly through the wizard here. Next, next, next. We'll assign this one the drive letter of Q for quorum, or we could do W for witness. Take your pick. and hit next. We'll go ahead and call this one quorum. And that's it. Next, create and close. And shared storage is officially configured. Now we're ready to form the cluster. Before we do that, let's take a pit stop back in the ISE here, because one thing that we're going to need to do is install the failover clustering feature on both of our nodes. So we can run the install Windows feature here targeting failover clustering. This will install it and just take a second on both nodes, and it will not require a restart. Now again, we're going to do this in the GUI as well, but I just want to show you a couple of commandlets here. Number one, test cluster. The first thing we're going to need to do is validate the cluster to make sure all of our underlying components are properly configured, that we have storage, that our networking layer is configured, and so on. We'll see that in the GUI here shortly. But this is the commandlet that you would use to validate the cluster. Then, to create the cluster, you can use the new cluster commandlet. Now, the first one I'm showing you here is a single domain cluster, which means it will create the computer object in Active Directory. The second one is what you would use for a multi-domain or a workgroup cluster, because this will not create that Active Directory object, but rather it'll set everything up that we need to inside of DNS. All right, let's head back into Server Manager. Let's drop down the Tools menu, and let's launch the Failover Cluster Manager. Let's go ahead and give the Failover Cluster Manager node here in the left-hand nav a right-click and choose to Validate Configuration. Give that initial screen a run through here and hit Next. Now we're going to enter the node names here. So we got CL1-NUG. We can go ahead and hit Add. That'll resolve to the fully qualified domain name there. Then CL2-NUG and hit Add. Perfect. From here we can hit Next. And all it's going to ask us here is what tests you want to run. It's going to recommend running all the tests, which we'll do. We'll go ahead and hit Next and then confirm it. And this will just give you an idea of what all the different tests that it's going to run here. Quite a few, just again to validate not only our hardware configuration, but all those layers here that we talked about. And this will take just a minute. So I'm going to go ahead and hit Next and let this run through. All right, my tests have just completed and all completed successfully. As you can see, both nodes were validated. You can hit the View Report button to get detailed information about the results. But if you did come across any errors, you wouldn't make it to this screen. You would be stuck on the previous screen with big red bold text over the items that failed, and then you can view again the detailed report to get information on how to resolve them. But we're good, so now we can hit this little checkbox here to create the cluster, and this will launch us into the new cluster wizard. So we're going to go ahead and hit Next here at the Before You Begin page, and now we need to give it a name. We're going to call this one, how about CLNUG? Just like so. We also need to specify the cluster IP. This is the virtual IP that's going to be associated with the cluster itself. I'm just going to type in, how about 150 here for our address, and hit Next. And that's it. We'll get our confirmation screen here. We can see our cluster name, the nodes associated with it. Our cluster registration is going to be both DNS and a computer object in Active Directory. There's our IP address. And if this box is checked, all the shared storage will be added into the cluster. If you uncheck this, you can still add it in after the fact. But I'm going to leave that checked, hit Next, and this will just take a second to create the cluster. And we're done. And it pretty much automatically configured everything for us. Notice here our quorum mode is node and disk majority. It actually chose the smaller of those two disks and configured that automatically for us as a witness. Now, if you didn't add storage in like we did there, then it wouldn't have done that, and it would have just been node majority, and you would need to manually configure quorum. I'll still show you how to do that here, but we're done. We can go ahead and finish here, and what we should see is our brand new cluster, and it'll default choose the cluster itself, which will give us a nice overview page about this cluster. Notice here that it's set up 3 networks automatically as well. And there again is that witness, and then it shows us our current host inside of the cluster, which is CL2NUG right now. But if we expand this, we can see roles. We haven't installed any clustered roles yet. We'll get there. We're a few nuggets away from putting a workload onto this cluster, but we will certainly get there. If we choose nodes, we can see both of the nodes involved. We can see they're both up, their current vote. If we expand storage here, we can choose our disks. And notice here that we have 2 of them. There's our available storage, that's our 100 gigabyte disk, and there is our disk witness, that 1 gigabyte disk. If we head down here to networks, we can even see that it properly configured our networks. So network 1 here, and if you click on it, you can see this is our 1 network, is both cluster and client. And you can rename these here. If you give it a right click, head down to properties, we can rename them. We'll call this one, how about company network? And notice that it configured this here to allow cluster network communication as well as clients onto this network. So it detected that this network can get outside and that it is our public network. So it went ahead and automatically configured this for us. So we'll go ahead and hit OK there. Now our second one, this is going to be our storage network. And if we right click and go on the properties here, you can see, by the way, that this is the 3 network. This one will not allow cluster network communication or clients onto this network. So this is purely for our storage. So this is good. It found this automatically as well, and we'll rename this one here to storage network and hit OK. Our third one then is for cluster communication and intranode cluster communication. If we right click and go on the properties of this one, notice that's our 2 network here, and we can rename this one to cluster network. And notice here that this will allow the cluster network communication on this network, but not clients. So it knew based on our connections, based on what we had iSCSI, and based on if it could get out or not, which network belonged to which one. But you can override this and customize it here with these 3 options. And that's it. Our network is configured. Now let's head back up to our cluster, to that nice overview page. Again, here's where you can perform a lot of your common management tasks. You can configure roles here, revalidate your cluster, add more nodes into the cluster, and configure cluster aware updating, which we'll cover in the following nugget. But what I want to show you here is how to configure quorum. If you were to right click on the cluster itself, head down to more actions, and choose configure cluster quorum settings, this will launch us into yet another wizard. So let's go ahead and hit next. And you can see the default here is for the cluster to figure out and automatically determine our quorum options. And because we had 2 nodes here, we had an even number of nodes, and we had a disk available, that's why it automatically configured one of those disks as a witness. Now, if we were to leave that and choose next, it'll show us what it determined for quorum. But let's say that we didn't add those disks in when we created the cluster. We were going to do that separately, and we still had an even number of nodes. Well, we would need to come in here and manually configure this. Here's where we could choose our second option to select our quorum witness and hit next. If we did add those disks in after the fact, we could choose the first option here, and then we could choose which disk we wanted to for quorum. And if you have a lot of disks in here and you didn't like what it automatically chose, you could come here and change that as well. I'm going to back up here because if you didn't want a disk witness, you could also choose an SMB file share as a witness. You hit next, you browse to your file share, and you're done. The third option here is, again, a cloud witness, which will use blob storage up in Microsoft Azure. If you choose that and hit next, then you'll enter in your account name and your key and your service endpoint, and you're done. So I'm going to hit previous here, and I also want to show you one more thing here. I'm going to head back to the very beginning and choose the third option here, which is advanced quorum configuration. If we hit next, it's going to stuff another screen into the wizard here before all those other ones that will allow us to choose which nodes have a vote. So we can pick and choose which nodes have a vote. If we didn't want any of our nodes voting, then we'll at the very least need to have a disk witness out there. But we're good. We're going to choose all nodes. In fact, we don't even need to step through this wizard because quorum is already configured. So I'm just going to cancel out of it. Now, a couple of more things that you should always verify after you create your cluster. Number one, if this is a single domain cluster, we should verify that the CNO, that's the cluster name object, was correctly registered in Active Directory. And we should also verify that our A record in DNS was correctly registered. Let's start in Active Directory here. We'll do this the quick and easy way. Right click on Start, head up to Run. We'll do a DSA.MSC to fire up Active Directory users and computers. And there it is, CLNUG. So again, this is known as the CNO, the cluster name object. It's the virtual network name for our cluster. So this is the name that will resolve to the IP address that we're going to look at here for that A record in DNS. And this is what our front ends will use to connect to the cluster. So for instance, our front end application developers will tie this into their SQL Server connection strings. And this will then resolve to whichever node is the current owner of that resource in the cluster. And speaking of DNS, let's also fire up DNS Manager here. We'll right click on the Start button, head to Run, type in DNSMGMT.MSC. And let's head right into the NuggetLab.com primary zone here, and there it is, CLNUG with its IP address. So those are all the pieces that need to be in place. If this didn't get created for whatever reasons, and there are many reasons that could happen, I've been in a few situations myself, what you want to do is find the root cause and then retry the process. You don't need to build the whole cluster again. What you can do in Failover Cluster Manager is come down here to your network name, the actual name of your cluster here. You can right click on this resource and you can take it offline. When you take this offline, then you can right click on it, go into more actions, and repair. That will reattempt DNS registration. And again, that will be successful then if you fixed the root cause of your DNS issue. And that's that. We have a 2-node cluster ready to go. We don't have a workload on it yet. We'll certainly get there and witness the true power of failover clustering. But this gives us a great starting point, and it's where we'll pick up in our next nugget. In this CBT Nugget, we learned how to create and configure a failover cluster. We configured a nice SCSI shared storage layer, we formed a 2-node cluster, and also saw how to configure networking and quorum. I hope this has been informative for you, and I'd like to thank you for viewing.